Hello, I'm Dr. Roslyn Oluwaseun Ogundokun, a lecturer and a researcher in the Department of Computer Science, Landmark University, Nigeria, and also a postdoctoral fellow in Tshwane University of Technology, Pictorial Soshanguve Campus, South Africa. I'll be introducing us to the topic AutoGrad. I'll be defining what AutoGrad is and why it's important and why AutoGrad is useful and important. So what is AutoGrad? AutoGrad is an automatic differentiation engine in PyTorch that computes gradients for tensor operation dynamically. And it records the sequence of operation in a computation graph and automatically calculates derivatives using backpropagation. So why is AutoGrad useful? AutoGrad useful for one, automatic gradients and calculation. It's normally used to eliminate the use of manual differentiation, making model training easier. Second usefulness is that it provides efficient backpropagation, which means that it enables automatic computation of gradients for deep learning models. And then the third usefulness is that it encourages dynamic computation graph, which means that it supports on-the-fly graph construction, allowing flexibility in model design. And the fourth but not the least usefulness from my side is optimization support. It means that it works seamlessly to optimize like Adams. It uses optimizer like Adams, SGD to update model parameters. Now, I'll be run us through the implementation of using AutoGrad. And in this case, we'll be discussing simple graph. So the first process we do, that is trying to build a computational graph. We are trying to build a computational graph, and the first step is to define our class. And here our class is the simple graph, as you can see on the screen here. And then after we define our class, we define our parameters. And in this case, our parameter here is W and B, which are in form of floats. They're in form of floats, and the W is a float that initiates the value for weight, and also the B is a float that initiates the value for biases. And here where we have asserts is trying to make sure that the parameter W and B are in float formats. They are in float format. And then here we have self W and self B. It's trying to ascertain that these parameters are in PyTorch tensor. Since we are using PyTorch programming language for this implementation, we make sure that every of the parameters we are going to be using, every of our call, every of our extension are in PyTorch tensor. So this self W and self B make sure that our parameters are in PyTorch tensor. And then we move to forward pass.